Recall that we wrote an equation for the yellow skeeter population that was y equals 2 to the x. We also wrote an equation for the green skeeter population that was y equals 3 to the x. Would it change the values if we had written those equations as y equals 1 times 2 to the x and y equals 1 times 3 to the x?
No.
Why?
Times by 1 doesn't change anything.
Okay? Because we are multiplying by 1. We are going to learn a general formula today. It is of the form y equals 1 times v to the x, where y still represents your, what'd you put on the y-axis? Total population. X represents your
Number 6.
shake number. B stands for the factor by which the population is growing, and 1 represents your, any guesses what the 1 represents? No? Initial population. Example 1, write an equation that would model a population of skeeters that grew by a factor of 3. So we're using the form y equals 1 times v to the x. So when we're writing equations, we leave the y alone and leave the x alone. When we're just writing an equation, we're not solving for it. So what we need to put in is the factor. So y equals 1 times, what's our factor?
3.
To the x. It's a factor of 3. So we put it in for b. Write an equation that would model a population of skeeters that grew by a factor of 6. So y equals Haley. What does y equal?
1
Times?
3.
No.
Oh, sorry, 6.
To the x. So it's a factor of 6. In the following 3 examples, you use the initial population and the factor to chart the first 3 shakes of each population. Then use your chart to find the growth rate. So Keith, how do we find the growth rate?
It would be new subtracted, new minus old divided by old.
Okay? So we have to find the first 3 shakes, and then we need to find the growth rate. So if a population is increasing by a factor of 3 and with a starting population of 1, what is the growth rate? So at shake 0, how many do we have?
1.
1. And it's increasing by a factor of 3. So what are we doing with that 3? Multiplying. So we have 1 by 3, which gives us 3. So then our previous population is 3. Multiply it by a factor of 3, which gives us 9. And 9 by 3 gives us 27. All right, we have completed the chart. So now we need to find the growth rate. The newest population is how much?
27.
Minus the previous population, which was
9.
divided by
9.
27 minus 9 gives us 18 over 9 simplifies to what?
2.
2. So my growth rate as a decimal is 2 or 2.0. So what is it as a percentage? It is 200%. Example 4. If a population is increasing by a factor of 12 with a starting population of 1, so factor of 12, starting population of 1, what is the growth rate? So at shake 0, what do we have?
1.
What do we do with the 12?
Times it by 1.
Okay, so 1 by 12 is?
12.
12 times 12 is?
144.
then our last population would be what?
One, 2, 8, 88.
No.
Oh,
1,728.
Okay. Thank you.
that was that.
All right, now we can find the growth rate. What's our newest population?
1728.
1728. Subtract the previous population, which is,
144.
and divide it by.
144.
Equals 1,584.
1,584 divided by 144.
11.
Okay.
And that's 1,000.
Very good. 1,100%.
Ooh.
Example 5. Population is increasing by a factor of 3.5 and it has a starting population of 1. So at shake 0, how much do we have?
1.
At shake 1, we have.
2.5.
At shake 2, what do we have?
12.25.
And at shake 3, what do we have?
42.87.
So let's find the growth rate. My newest population is
2.875.
minus the previous population was
25.
divided by. So 42.875 minus 12.25 gives us
34.65.
divided by 12.25.
Wait, what is it?
2.5.
30.625.
2.49. That's what it is.
2.5.
2.5?
2.49.
I think you rounded.
I don't know.
You don't think so?
That's what I got.
I think you just got it wrong.
It's
You think
2.5.
I got it wrong?
No, I think Austin got it
It's
wrong.
2.5.
It is 2.5.
Oh.
So what is the growth rate?
No.
250%.
Liar.
You call me a liar?
No. Call Austin a liar.
Okay.
He called you a liar.
Austin. What?
Example 6. Write down the factor of example 3. What's the factor for example 3?
3.5.
What's the factor for example 3?
Oh, 3.
And its corresponding growth rate as a decimal.
2.
B. Write down the factor of example 4
12.
and its corresponding growth rate as a decimal.
11.
Write down the factor of example 5 and its corresponding growth rate as a decimal.
3.5 and 2.5.
What is the correlation between the factor of a population and its growth rate?
It's one less.
What's one less?
The
Growth rate.
Or we can say the factor is
one more.
one more. All right, so we mentioned this yesterday, but you didn't get to see it that well. The factor is one more than the growth rate. As a decimal. We're going to be looking at different populations. We're going to be looking at money. I'm going to give you an equation sometime, and you guys are going to be able to determine what the growth rate is, what the factor is, going back and forth. because of this relationship. Now let's go in reverse order. If the growth rate of a population is 500%, by what factor is the population growing?
6.
Growth rate is 500%, which is 5 as a decimal. So the factor is 1 plus that, which is 6. Good. Bless you. Example 8. Growth rate is 350%. What is it as a decimal?
3.5.
So that means that the factor would be,
4.5.
very good. One type of skeeter produces 3 offspring for every shake, whether the mark side is exposed or not. Create a table showing the first 5 shakes and total population. So at shake 0, how many do we have? 1. So this skeeter produces how many offspring? 3 offspring. So 3 offspring. So I have a total population of
4.
So that means my factor is
3.
4.
4. It is 4. Because remember, this was a factor of 3, so 1 times 3 gave us 3. 3 times 9, and so on. This one, we have a total population of 4. That means our factor is 4. So at shake 2, how many would we have? Factor of 4. We're multiplying by 4. Because remember, each one of these produces 3. So then that gives us 4, 8, 12, and 16. So after the third shake, how many would we have? 64. Fourth shake, we would have 256. And sixth shake,
1,024.
1,024.
What? I like how you saying that. I thought I didn't even get this number out of my mouth, but.
Write an equation of the form y equals 1 times b to the x that models the growth in this population. So y equals 1 times 4 to the x. Determine the population after 15 shakes. So how would I do that?
4 to the power of 15.
4 to the power of 15 gives us
1,073,741,824.
Can't read that. Why not? 1,073,741,824 skeeters.